Hi everyone, my name is Mike Davis and I'm a professor of UAS technology at our local college and a FAA safety team representative. This presentation is module 4 of a 6-part series designed for utilities. The topics we'll be covering today will be focusing around both large and small operations, site evaluations, mission objectives, and also how we're going to handle data management. In large enterprises, they typically have multiple districts in a dense population area. They usually have a large staff, and they have dedicated vertical market teams. Whereas in smaller districts, they cover a large geographic area, but in very sparse population areas. They have less employees, and this individual person is typically multitasking or have multiple roles. Environments change. What it was like last week is not what it will be like this week. A set pattern may have to change to achieve the needed results. Whether it's a large organization or small, it's the same sense of safety and procedures. Either large or small, we're trying to do and accomplish the same thing. We're out there capturing. We want to do an analysis to that. And from that analysis, we want to generate an action plan. And the action may be nothing, or it may be something that's critical. But with any organization, same process: capture, analyze, and devote an action. Small or large organizations, single pole capture in distribution is typically the same. The pole distance is closer, and distribution lines are typically throughout the populated areas. Flying under Part 107, remember, restricts flights over people unless you have a waiver. Now, capture teams usually take 2 photos, one each side at an oblique angle, and then they go on to the next pole. However, a photo may be taken down the right-of-way, which will pick up obvious issues. Single pole distribution inspection capture is relatively straightforward and allows the operator to move from one pole to another very quickly. Without a beyond visual line of sight waiver, is still the easiest method. You fly one direction and then you turn and you fly the other. Since each photo captures the lat long in the photo's metadata tag, their relative position stays with the photo. Capturing larger transmission lines increases the challenges and demands on the pilot. Training for mission-ready status is increased to ensure safety and competency with the pilots. The general flight pattern or process is followed by allowance to the camera operator and the pilots that are made. Flight positions are adjusted for the weather, sun angle, safety, and the observation for problems. The pilot and its teams have demonstrated skills to see potential problems and take the necessary photos. Now, we want to make sure you have a good, clear picture so we can see details of connections, pins, nuts, washers, and then when we're back in the office reviewing this. So we have to make sure that the lighting and the clarity is very good. Now, you may need to switch to a manual focus while in the air. Now, if you don't know if the picture is good enough or covers everything, take another picture, or take 2, take 3. It's better to have too many than not enough. The flight path demonstrates 10 different locations in this example. Each position may require more than 2 to 3 photos depending on what is observed. This example is shown is a 230 kV line. In this pattern, you would shoot a nadar of A phase pole, or position 3, and then try to capture as much detail as possible. Taking a picture looking down the pole must show the static wire connection, all bolts, all washers visible for analysis in the office. Now, your goal is that you should be able to see the entire assembly with bolts, washers, ground connections, and pins. The same goes to a series of photos for C phase, or position 4 in this example. Position 5, you fly out past the C phase end of the arm, hover down until just below the arm level. Position the drone so that you get an entire top of the structure, including the static wire connections, down to the insulator shoe on the conductor with nuts, bolts, washers, and cotter pins that must be visible. Position 6, outside the insulator arm to the arm, you will need to maneuver so that you are getting a clear shot of the end of the pin that has the cotter pin in it. Position 7, lower end of the insulation with a cushion grip and its pins. Inspect the insulator sheds as you are maneuvering the camera around the insulator. From the outside positions, positions 6, 7, 9, and 10, you should be able to view the center phase insulator and the connectors, and you want to position the UAS so that you can see cotter pins and take the photo. Position 6, 7, 9, and 10 from the previous illustrations covers the center insulator. Once done on C phase side, fly up above the structure and maneuver over to A phase side to the pole and repeat the process on that side. Do not fly under the wires. Now, before leaving the site, run down your checklist. Now, there are just a few items that you need to be aware of before takeoff and before leaving the site. Here are a few notes that you want to be sure that's done. But before you leave the site, make sure that when you're looking at the photo, the focus is good, the sun angle is correct, and you want to think to yourself, did you miss any connection, any cotter pins, or any insulators? When the images get back to the office, the analysis teams will review each picture. They may use zoom methodologies to get in closer. This is why that when you're in the field taking the picture, the clarity of the picture is critical. The analysis team, while they're in the office, will tag any problems. And of course, they will advise the field technicians through a process. But typically what will happen here is that they'll tag them, just what you see on the upper left of the pictures. Now on this slide, notice the action steps that they're taking. Actions include all of these steps and must be recorded and saved for a comparison later on. Discrepancies are recorded and work orders can then be submitted accordingly. Now all steps lead back to updating the database. The work step may be as simple as submitting of reports if no discrepancy are found to the submission of the work order or to fix a problem. All of it is fed, however, back into the software tracking system to close this loop. So you'll see capture, analysis, action, and a work or a work order, depending upon even if there's no discrepancies, it will go back in and be updated to the database. It circles and completes the circle. Now, reports are very important to keep the teams informed. Discrepancy reports could be sent along with work orders. Management reports can be sent to the department supervisors, or even historical data can be assembled on a quarterly or even annual basis to submit to the stockholders. In summary, distribution lines will have less picture, you'll be in closer proximity, and you'll be able to do more polls quicker. Analysis is usually conducted in post-flight. It's easier flight planning, easier for operational training. Whereas transmission lines are farther apart than distributions, you're going to require more pictures, more flight time, and inspections occurring during and even after flight. So you're actually looking for anomalies while you're flying. This requires a higher flight skills. The reason why I want to show both of these is that mission ready status for a pilot is higher with transmission lines. The other things that can be done in which you want to consider with utilities is that you can also use drones for corridor flights as well as surveying vegetation, transformers or substations, roof inspections, and of course thermography. Some of the critical needs that you must have in hand is your operations manual, because you need to know your mission, the task, and the procedures. You need to have a training manual, and we'll talk about this later on. You need to know your flight requirements, the train and recurrent training. You want to ensure mission-ready status for all the pilots. Management software, this ensures your compliance. It keeps track of inspections, your personnel, if necessary, and any necessary documentations. And then, of course, the actions. More or less, how do you manage the data? What do you do with work orders? All of this, we have to remember, at the end of the day, it's all about the data you collect. Thank you for joining me on this module. There'll be other modules. You can also contact me at any time and contact me through the website and to look at the other modules as well. So see you soon.